Hello and welcome to my first video for well over 3 months. I haven't been doing videos because mostly because I'm just bored of flat Earth. I'm bored of everyone involved in it. I have no respect for it at all. It's a joke. However, these characters, Globebusters, made a video about me yesterday, going through a video that I'd made, 25 flat Earth bad memes, trying to do a hatchet job on it. I wasn't sure how to respond to this because it's about 2.5 hours long. So what I'm going to be doing is just over the next, days and maybe a week or so, just making little videos, just going through certain points and just explaining why what they're saying is just complete garbage. But I thought I'd kick the thing off by returning the favour to one of them, Jeranism, by looking at a video made well over a year ago, which is kind of like a mirror image of what I did. He's going through 10 reasons why we know that Earth is a sphere, and he thinks he's debunking them. So I'm going to just talk through what he says and just show it's just the total dishonesty of this guy, his utter dishonesty. Let's listen to what he says.
Jeranism, here again, this time, answering those who said I wasn't bringing any evidence, so I decided I'd just debunk the minute physics 10 reasons we know the Earth is flat. So here goes, 10 reasons, 10 debunked. Click the link to watch those first, or follow me. Number 10, the other planets are round. Telescopes are made with convex lenses, folks. Before them, all anyone saw in the sky were stars and wandering stars. That was it. Egypt worshipped the lunar disk, and the ancients worshipped the solar disk. Here's my photo of the lunar disk. Not a sphere, one side always faces us, no hotspot because it's a disk. Number 9.
Well, for a start, telescopes having convex lenses has nothing to do with it at all. I don't know why he mentioned that. Let's look at this video that shows us a time lapse of the moon going through its phases. Now, if you want to claim this is fake, that's your business. But you can get a telescope and look at the moon and see this for yourself. How anyone could look at this and claim that this is a flat disk is beyond me. This is clearly a spherical object with light shining on it from different angles. How is that in any way, shape or form a flat disk? I mean, you can actually see shadows being cast by the craters as the light from the sun moves round. That is not a flat disk. Anyone who says it is either a liar or they're not entirely sane.
Time zones. No edge jokes, just edge understanding. Here you can see the sun circles atop us, and look at that. It makes a great little timepiece, doesn't it? And the sun, the moon, and time all go clockwise.
You could have time zones of sorts on a flat Earth. They wouldn't work like the time zones that we see because the sun would never go below the horizon on a flat Earth. Also, if he's endorsing this idea of the sun going around the North Pole, then what we see completely contradicts that. All you have to do is ask someone in the southern hemisphere at the moment what time the sun's rising at, and what direction the sun's rising at. They'll tell you that it's rising south of east, which completely contradicts this model. I've gone through lots of reasons in my videos you can watch why this model doesn't work. It fails on so many levels. It's comical that anyone would even say that they take it seriously. It's a joke. Anyway, let's move on.
And the sun, the moon, and time all go clockwise. Number 8, the Coriolis effect. We will kill 2 birds with 1 stone when we get to the stars.
He doesn't give any explanation of it at all.
Here's a quick clip about number 7.
Triangles. If you walk 10,000 kilometers straight along the Earth's surface, turn 90 degrees to your right, walk 10,000 kilometers more, turn right again and walk another 10,000 kilometers, you'll be back to where you started, having successfully made a triangle with 3 90-degree angles.
So, we can do the test here. You can watch me on Google Earth, but let me explain it first. This would prove absolutely nothing anyway. The test he gives assumes that we're on a globe. Is the walker going straight, or is he going on one of your latitude longitude lines? Here's the thing. The reasons it doesn't work is because to make it work, you have to start at the pole, where all the lines meet. So yeah, guess what? You walk down any one of those lines, then walk across, you can catch any line that you want back to the top of the pole. It's called cheating. It's called misleading. It's a lie. I won't continue.
For him to say that it's cheating and it's lying and it's misleading in light of what he just said is mind-boggling. What he said is, it's hard to even respond to it because it's complete nonsensical garbage. I'm reminded of a famous quote attributed to the physicist Wolfgang Pauli when he was shown a piece of physics that he didn't think very much of. He just shook his head and said, "This isn't right. It's not even wrong." That's what I feel like watching this. It's not even wrong. It's just garbage. It's got nothing to do with lines of longitude and latitude. I'll try and explain why what he says is misleading, and I'll try and show you how to do this properly on here. On a sphere, you can draw circles that are called great circles, and a great circle will actually cut the sphere right in half. An example on the Earth is the equator. Also, all the lines of longitude are great circles because they pass through the North Pole and the South Pole, and they cut the sphere in half. Now, great circles on a sphere join points together over using paths of least distance. I shall explain what I mean by that. So, if I join 2 points on the equator, you can see that any 2 points that join on the equator, the line will follow the equator along. That's because the equator follows paths of least distance between 2 points. And you'll find the same with lines of longitude as well. Now, lines of latitude, apart from the equator, do not follow paths of least distance. So therefore, what he's talking about is going from the North Pole down a line of longitude, and then along a line of latitude is not what that guy's talking about in that video. Because lines of latitude do not connect places along paths of least distance. As you can see here. This will give you the path of least distance. Now, if you followed this line all the way around and got right back round again, you would form a great circle all the way around the Earth. So what he says is just nonsensical garbage. It's got nothing to do with lines of longitude and latitude. It's got nothing to do with the North Pole. Now, if I can show you I can demonstrate on here how you could how to do this properly. So if I draw a large triangle on the Earth like this, I can get a protractor up and I can measure the angles. Let's move this out of the way. So let's measure the first angle here. So that one is, I'll just write that down. That's about, we'll just say that's 90 degrees. And that one there, so we're using the outer scale there, so that one's what, 64 degrees. And the last one, let's turn it around. So we're using the inner scale here. So what's that? About 81 degrees. So we'll add these together, 90 plus 64 plus 81, and you get 235 degrees. Now, as any school pupil will be able to tell you, the angles in a triangle should add up to 180 degrees, which is what you'd get if it was on a flat surface. They don't add up to 180 degrees when you draw a triangle on a sphere. Now, it only counts as a triangle if you put 3 points on the sphere and join them up with paths of least distance. And like I said, these paths of least distance, if you continued them, they would form great circles, like the equator or like long lines of longitude. But lines of latitude don't form great circles, so the kind of triangle that Jeranism is talking about creating doesn't count. It's got nothing to do with it, and it's got nothing to do with these lines of longitude and latitude, like I said. What he says is it's just garbage.
To bore you with this one, simply go get Google Earth, play with it yourself. It's impossible. The only way out.
Well, I did, and I just showed you that it works.
This is by starting at the top of the globe, which is cheating. All you're doing is taking one of the lines down to the equator across, and one of the lines back up. You can just take a look at these 3 right angles right here. I think those angles look pretty acute to me when you turn the triangle over. The sun, as we've explained, sets out of your field of view on the horizon, gets smaller as it goes away from you. He mentions the ability to use the sun to get the circumference of the Earth, which works if the sun is 93 million miles away, but also works if the sun is 3,000 miles up and 32 miles across. Number 5.
No, it doesn't. I'm going to go through that claim there. I've mentioned this plenty of times before. I've made videos about this kind of stuff. Right, on a spherical Earth, the sunlight is all taken to be parallel like this. If you were here, say that you were standing at a point here on the Earth. Now, it's a circle now. A circle is a cross-section of a sphere, so this works for a sphere as well. The sun would be directly over your head. Now, if you go a certain distance along, the sun's now at an angle. Now, this line here shows you the local horizontal at that location. And we can measure what's called the angle of incidence of sunlight, which is the angle measured against the vertical. So you can see it's about 20 degrees. It should be about 20, but sometimes that doesn't give you a very good answer. So yeah, about 20.4 degrees. If I rotate around again further in the same distance, you find that the angle, the angle that the sun is deviated from the vertical, the angle of incidence, will have pretty much doubled. Yes, so it's 40.2 degrees. So you find that on a spherical Earth, you would expect that this angle here would have a simple relationship with the distance from where the sun is directly overhead. You double the distance, you'd expect the angle to double. And that's exactly what we see in the world. And that's why we have lines of longitude and latitude. They're related to the sun, as well as locations. You can use, and I've made a video about this, made it about a year ago, you can use the angle that the sun appears in the sky at solar noon at any location to measure your latitude, and indeed sailors used to do that. You can also use Polaris. You couldn't do that on a flat Earth because the angles, the geometric relationships don't work out. And if you look at a flat Earth, now say you're a distance 10 whatever it is, from the place where the sun is directly overhead, and you measure the angle that the sun deviates from the vertical, say it's 51 degrees, 51.4 degrees. If you double the distance, the angle doesn't double, it doesn't even come close to doubling. It's a different relationship on a flat Earth. The relationship between this angle and how far you are from where the sun is directly overhead is a totally different relationship on a flat Earth. It's not the one that we observe. Now, the upshot of that is that if you're assuming that the Earth is flat and you try and use these angles to estimate the height of the sun, you'll get a different answer depending on how far away you are from where the sun is directly overhead. So you don't get a consistent height for the sun assuming a flat Earth. It doesn't work. Essentially, the further away you are, the lower an estimate you'll get. So there is no consistent estimate for the height of the sun on a flat Earth because the angles don't work out. Because the relationship, like I said, between this angle and the distance is a simple linear relationship. You double the angle, you double the distance, and like I said, that's why we have lines of longitude and latitude. It all fits a spherical Earth. None of it fits a flat Earth.
Stars change going north or south. Why, yes they do. Why don't we explain why that happens? Here are the stars. You all know about Polaris, right? It is in the north. So you can take your position here on our star chart, look up north, see where Polaris is, and watch which way these stars rotate. We all know that the stars rotate counterclockwise when looking at the north, and so you get the confusion of people saying, well, what about the south? They rotate the other ways. Well, let's watch. You can see that they lift to the upper right, going up that wall, counterclockwise. So let's keep following that. Remember that, up this wall, up the wall. Keep rotating to the right, up the wall, up the wall. We keep going a little bit more, up the wall, up the wall. We're getting towards the south, they go up the wall. Look at that. Now they go clockwise. That's all it is. There is no southern pole star. They're all rotating the same direction. It's like a big tunnel rotating above us. And if you think about it, that is the same thing for the Coriolis effect. They tell you that in the northern hemisphere, tornadoes go one way, the southern hemisphere, tornadoes go another. This is your explanation. Depends on which way you look. Everything rotates the same way, but there's always the eye of the observer. Magellan circumnavigated the Earth.
This is another case of he's not right, he's not even wrong. It's just garbled nonsense. There are two centres of rotation for the stars on Earth, one in the north and one in the south. Whether there's a southern pole star or not has nothing to do with it. Flat earthers bring this up as if it's some kind of get out of jail free card. It's not. It's the fact that the stars are rotating around a fixed point. That's what matters. Now, what you're seeing here is a location on Earth, presumably somewhere near the equator, where you can see both of them at once, to some extent. Basically, if you're in the northern hemisphere, you'll see a centre of rotation for the stars, which is always due north, no matter where you are. If you're in the southern hemisphere, you'll see a centre of rotation for the stars, which is due south, no matter where you are. Okay, there is no way you can explain that with a flat Earth model. Other people have made videos about this. Mari Ziller made an excellent video about this. You can look at his channel. It just doesn't work on a flat Earth. Now, further to this, the flat Earth model would have the stars moving in a giant above us in a giant circle in a plane. Well, if that was the case, perspective would mean that you wouldn't always see them moving in a perfect circle. The further you were away from the centre of rotation, the more flattened out they would look. They would start to look like they were moving in a kind of oblong shape. But wherever you are on Earth, you still see a perfect circular shape like this. Again, completely consistent with a spherical Earth, not consistent with a flat Earth in any way, shape or form. And what he says about the Coriolis effect is just utter nonsense. This whole section of what he says is just garbage. It's garbage.
Sure, many of you have before. No edge jokes, just understanding the edge. Make a circle going west and you'll end up exactly where you started.
Yeah, if you're constantly turning as you're sailing, if you sail in a completely straight line, you can circumnavigate the globe, or fly in a completely straight line.
The horizon. We've all seen the Globetrotters swear by this one. But here's the tip. When the boat gets out of your line of view and starts to drop behind the curve, get a telescope and guess what? It'll reappear because globe edges hate telescopes.
No, that's one of the biggest lies going. I mean, I've already made a video about this. I mean, if you look at this video, someone zooming in on Toronto, I mean, you can see it doesn't matter how much you zoom in. The amount of Toronto visible is constant. It doesn't change. You don't see more of it as you zoom in. I've demonstrated similar things with the horizon. I made a video where I looked down the river where I live and showed the bridge. Now, this is a video I made to back up. Now, unfortunately, not that many people watched it, but it's probably better than the video that most people have watched. I mean, what I've done is I've taken footage of this bridge at two different places, well, close to each other, but at two different heights. This is taken at about 40 feet above sea level, and then this is taken at about 4 feet above sea level. And you can see, as I compare them, I've superimposed one bridge on top of the other, so you can get a direct comparison. You can clearly see that the bottom of the bridge starts to be obscured when you're lower down. Now, further to this, if you look at this tree line here, and if you look at this shape here, you can see that same shape in the other video, but moved over a little bit. Now, look how much of the trees are visible there, and you go down below, there's that same shape there. The trees are almost totally obscured. Now, this shows that the further away something is from where you are, the more it gets obscured by the horizon. And by zooming in, you can't see any more of it. I mean, you can look at the other video I made about this where I zoom in and out. You can see that you don't see any more or any less. All you're seeing is things looking bigger. There's no reason at all to believe that zooming in on something in the horizon would show more of it. Now, flat earthers are always talking about these videos where they think it shows this, but it doesn't. All these videos are showing is the camera zoomed out. So it's zoomed out to such an extent that you can't see something because it's too small to be seen. That's not the same thing as being over the horizon. It's just too small. What you're doing here is when you zoom in, you're just making it bigger so you can see it. You're not looking over the horizon. And you can see that there as this camera zooms in. You're not seeing more of it, it's just getting bigger. You know, it's the same, like I said, with this video of Toronto, and there's a few other videos you can see like this. The exact same amount of Toronto is visible, no matter how far away you're looking at it. So this thing about seeing things over the horizon with a telescope is a complete lie. Ask anyone who's a sailor if that's true, or a navigator. If that was true, ships would never have had crow's nests. They have crow's nests so you can see over the horizon. It's why it's why lighthouses are built on the top of towers, so they can reach out beyond the horizon, not beyond the horizon, so they can see as far as possible over the curvature of the Earth, so people can see them further away. If the Earth was flat, you wouldn't need to build a lighthouse on top of a tower. It wouldn't matter how high you built it, you would see it anyway. Right, anyway, let's go on.
Then he drew a picture and he said if flat Earth was true, that you'd see Chicago from Michigan. Superior mirages, anyone? Yes, they're superior indeed. Then he drew the Rockies behind his buildings and said if Earth was flat, we'd be able to see those too. Because everyone knows that smog, fog, exhaust, heat, mist...
This is just, I don't know, it's just irrelevant.
And dirt don't exist. See here? Those cannot contain color. If you had a blue aura around you, what they're doing here. One thing is for sure, shadows cannot contain color. If you had a blue aura around you, would your shadow turn blue? No.
It's not that the shadow of the Earth is making the sun red, it's the light being scattered from the atmosphere of the Earth. You know, the Earth has an atmosphere around it. So even though the light from the sun is being blocked by the Earth when the Earth is in the moon's when the moon is in the Earth's shadow, the light is also being scattered by the atmosphere, and that's why you get this red effect on the moon. It's no problem at all with that.
Second, many reports exist where the sun and moon were both above the horizon and a lunar eclipse took place. That cannot happen unless they're messing with the moon. The eclipse is simply not what you think it is. Last but not least, number 1, photographic evidence. Oh, seriously? Oh, okay. We'll take an image, check to see if it's a composite, which most are. Check others. Look for anomalies and...
Yeah, NASA put out some really bad images of the Earth. There's no doubt about that. It doesn't prove anything. As I've always said to flat earthers, even if you could prove every single image from space was faked, it still wouldn't prove anything about the shape of the Earth. And we do have real images from space. If you go to Sean Hufford's channel, he's put together images from a Japanese geostationary satellite. Now, it doesn't really there's no point in showing stuff like this ultimately to flat earthers, because it takes no effort at all just to say that's fake. Flat earthers allow themselves to dismiss evidence carte blanche with no explanation at all, other than just to say it's fake. Well, you can't prove that's fake. I know I can't prove it's real either. And that's why I never use images from space as evidence for the Earth being a sphere. But I've no doubt at all this is real. There's no reason to doubt that this is real. If you don't want to believe it's real, that's your business, but it doesn't prove anything at all about the shape of the Earth.
And take a deep breath, because ladies and gentlemen, you just realized that the Earth is flat. Take a look at some of these and you'll see that they're using stamp-on clouds. They're identical to other places on the images. All you gotta do is do your homework on this one.
Doesn't make any difference at all. Like I said, it proves nothing about the shape of the Earth. So, just dishonest nonsense from Jeranism there. Now, like I said, I'll start putting together responses to at least some of the things that they've said in this video. There's no way I'm going to be responding to 2.5 hours worth of these guys babbling. Mostly just lying and talking rubbish. But anyway, yeah, that's the end of this video, looking at Jeranism's debunking of 10 ways we know the Earth is round.